Cars, Crashes, and Collisions by Todd Gernert. This is a nonfiction text with the essential question, how are energy and speed related? Presented in 4 chapters. Let's begin. Chapter 1. Crash Car Stars. Can you imagine the feeling of jumping over parked cars in a pickup truck with giant wheels? That's what monster truck sports are all about. But it's more than big fun, it's big science. Monster truck stunts use motion and force. Motion is a change in an object's position over time, and motion is caused by force, a push or pull. All motorsports use a lot of force and motion. That means they can be dangerous. Monster trucks are specially built to protect the driver in a crash. When 2 or more objects crash into each other with force, it's called a collision. Motorsports are fun, but dangerous. Monster truck drivers wear helmets and fireproof clothing for extra protection in an accident. No matter why, when something crashes, it's called a contact force. Contact forces can stop objects or cause them to move, and they can do more. Here we see a car hits the wall, a foot kicks the ball, and a paddle moves that canoe. Friction is a force between surfaces that slows objects or stops them from moving. You can feel it when you push light or heavy objects. Friction also makes heat. Rubbing your hands causes friction. Not all forces need contact to work. Magnets can move metal objects without touching them. When you jump up, gravity pulls you down. Forces that work this way are called non-contact forces, like gravity pulling on leaves. Chapter 2. Newton's Laws. Around 300 years ago, the English scientist Sir Isaac Newton made an important discovery. He learned that motion is governed by scientific laws. Today we know them as Newton's 3 laws of motion. Newton's first law: objects in motion tend to stay in motion. Objects at rest tend to stay at rest. This law is known as inertia. It takes force to overcome inertia. Because of inertia, bowling pins stand motionless until they are forced to move. Newton's second law: forces can cause objects to move or change their motion. The amount of change depends on how much force is applied. Newton's third law: every action causes an equal and opposite reaction. In other words, for every push, there is a push back. Forcing air into a balloon is an action. It causes an equal and opposite reaction. The balloon reacts to the force by stretching and trying to force the air back out. Chapter 3. Need for speed. Anything moving has speed. Speed is how fast an object's position changes over time, at any given moment. Vehicles like cars and trucks allow people to go faster than they can on foot. They use energy to do it. Energy is the ability to do work. Cars and trucks need to carry potential energy. Potential energy is the energy that is stored inside an object, such as gasoline. Pushing the gas pedal starts a chain of events. Fuel goes to the engine, a spark burns the fuel, causing parts of the engine to move. The engine uses kinetic energy to turn the wheels. Kinetic energy is the energy an object has because it is moving. More energy delivers more force to the wheels. Friction between the wheels and the ground turns them even faster. Energy comes in many different forms. The sun gives off light energy and heat. Vibrations travel through the air as sound energy. Our phones run on electrical energy. Moving objects have velocity and acceleration. Velocity is the speed and direction of an object. Acceleration is a change in velocity over time. The United States Navy's Blue Angels use velocity and acceleration to perform at air shows. At times, they fly faster than the speed of sound. Chapter 4. Forces at Play. Bowling is a fun and popular sport. Bowlers roll a heavy ball at targets called pins. They score points when the pins fall. But how do energy and motion work in bowling? It all starts with you. The force you create in swinging the ball is transferred as energy when you let it go. The energy transfer is the movement of energy from one object to another. The energy transfer gives the ball velocity to roll down the alley, a distance of more than 18 meters or 60 feet. The ball has kinetic energy to transfer. Strike! The ball crashes into the pins. As it does, much of the kinetic energy goes to scatter the pins. You give energy to the ball, and the ball gives energy to the pins. Yet the total amount of energy stays the same. The amount of energy is unchanged because of another important scientific law: the law of conservation of energy. Energy transfers easily, but the total amount of energy remains the same. This is because the law of conservation of energy. This law states energy cannot be created nor destroyed, but it can change from one type into another. In other words, contact force from kicking a soccer ball becomes kinetic energy in the ball. Energy transfers don't change the amount of energy. Objects in motion can be a lot of fun, especially when you move them with friends.